Section 6.4 is using the inverse function. If we take a look back on what a regular function is, we had inputs, which were our x's, and our y's, which are our outputs, and our inputs were mapped to our outputs. That's how we got a function. An inverse relation, basically just the opposite. Our outputs are now mapped to our inputs, so essentially we're going backwards. So now, the domain of the inverse relation is now the range of the original function. If this was our original function, the y's now become the domain. Basically just flip-flop. So we're going to swap the x and the y values, essentially. The graph of the inverse function is the reflection of the graph of the original relation over the y equals x line. And you're going to do an activity in class that shows you the relation graphically. Let's go on to finding an inverse relation, actual example. I just said up top, you find the inverse relation by swapping the x's and the y's. So that is exactly what you're going to do. Where there's an x, you're going to put a y, and where there's a y, you're going to put an x. So flip-flop. So instead of having y equals 2x minus 4, you're going to write x equals 2y minus 4. And to find what that inverse function is, all you have to do is solve for y. So add your 4. And we have 2y equals x plus 4. I just flip-flop the sides and divide both sides by 2. So we have y equals x over 2 plus 2. And you're done. That's your inverse function. Why don't you go ahead and try this next one? And I don't know why it's written twice. My computer's being awesome right now. Go ahead and try it. Maybe pause it because I'm going to go ahead and do it. So pause it, try it, and then you can play the video again and check your answer. So to start off, switch your x's and your y's. So you have x equals negative 3y plus 6 and solve for y. So subtract 6. I'm going to go over here for my next step. So you have negative 3y equals x minus 6. Divide by negative 3, and y equals negative x over 3 plus 2. That is your inverse function. Alright, if two functions are inverses of each other, that means if we compose them, we should get x. So if you have two functions that say, hey, these are inverses, if you do f of g of x and g of f of x, doesn't matter which way you compose them, you should get x both times. And the inverse function is denoted by an exponent of negative 1. That means inverse. So if you had f to the negative 1, that would read f inverse. So if we have these two functions, we have f, and we're told that f inverse is right here. So this is the function, and this is f inverse. And they want us to verify that they are inverses. So if we compose these two, we should get x. And we have to compose them both ways. So I'm going to do f of f inverse first. And then I'll flip-flop it. So if I do f of f inverse, that means I'm going to take the inverse and put it inside the original function. So I'm going to write the original function, and wherever I see an x, put the inverse function. So I have an x, and instead of x, I'm writing a half x plus 2, and finish off the original function with the minus 4. So to solve this, distribute, and 4 minus 4 is 0, so I do get just x. But I also have to try it the other way, so I need to do f inverse of f of x, and see if I get x that way. So now put the original function into the inverse function. So I'll write the inverse function, where I see an x, put the original function, and distribute. So I have x minus 2 plus 2, and I end up with x. So this is inverses of each other. Now go ahead and try this example. Again, I'm going to show you the answer, so if you want to go ahead and pause it and try it on your own, see if you can do it, and then check your answer. you need to do both f of inverse of f of x and the inverse of f of x. And both of these should equal x if they're true inverses. So this first one, I write the original function, wherever I see x, I put the inverse. And here, just the opposite, write the inverse function. And where I see an x, put the original function. And I should get x when I simplify. I just have x minus 6 plus 6, and that is just x. And here, if I distribute, I have x minus 2 plus 2. So good, they are inverses. So in class, we're going to look at more of the graphs of inverse functions.